screen. Okay, so confirm if you can see my screen. I will just react. All right, awesome. Once again, it's really nice to be here to take you guys for the last time. And for this session, we'll be looking into front-end integration with your smart contract. Of course, in the previous sessions, you've learned how to write your smart contract, how to test your smart contract, and how to deploy your smart contract, both on local host, both in your local machine and on Sepolia and testnet. And for this session, we'll be looking into how you can now connect your front end with your smart contract so that your users can interact with your product. So for this session, I'll be working with the premise that we understand how React works, because we are basically going to be making use of React to connect our smart contract to our front end. So without further ado, let's get straight into it. So we can decide to make use of two methods. You can decide to make use of Starknet Js. You can make use of Starknet Js. You can make use of Starknet React. And also there's this particular toolkit called scaffold stack, right? So scaffold stack is like it's a framework, right? It's a tooling that enables you to bootstrap your project. So your front end and your smart contract will be in the same place. So you can easily deploy your smart contract and then test it on the go, right? However, for the focus of this class, we are going to be creating our front-end integration from scratch using React. So we're basically going to be spinning up a Next.js application. Then we are going to, let me make this bolder. So we are basically going to be making use of a Next.js application. Then we are going to integrate Starknet configuration right into it. So let's head over to JS. Let's just spin up a new, what's it called? Let's spin up a new, yes. So this is going to spin up a new Next.js app for us. And then we start with our configuration. What should we name it? Front end demo. TypeScript, yes. Slint, yes. Tailwind, yes. Source folder, yes. App router, yes. Appleback, yes. Defaults, yes. Yes. So this is going to initialize. It takes like a few moments. So now we are going to be doing a whole lot of plug and play here. You know, we're going to be making use of the documentation. So to begin with, we're going to be using our Starknet React documentation. While we wait for this to finish loading. So it's pretty much straightforward. Once you have your Next.js application set up, you first need to install Starknet React, core stuff, Starknet React chains and then Starknet React core. You need to install this first, and after which we are going to make this configuration to our Starknet provider. So this is basically what is going to allow us to connect with to connect with our wallets. So mind you, I need to make something known to you. You know, ideally when you're dealing with Ethereum smart contracts or EVM compatible smart contracts, that's when you're going to be talking about MetaMask. You can also use Phantom, of course, right? But within the context of Starknet, yes, there are certain wallets that you can connect to. That is, you have the likes of agents. This is agent here. There's agents. There's Bravos. There's there's cartridge, and of course, it's also been integrated inside of MetaMask, right? So let me see if this is done. Okay, yeah. So we have our project initialized. CD to front-end demo. Okay. So please, I need you to like carefully follow along because it's very easy to get confused at some point in time. So I'll try as much as possible to go as slow and as basic as possible. So and I have already deployed a sample contract. I think is basically what's this? I think it's the contract you guys worked on as well. So this is a simple contract. So this is a simple contract that increases balance, and you can also get balance. So we are going to work on the front end to integrate this smart contracts, to integrate this functionality so that your user can interact with it. So I've already deployed this on Sepolia already. So I'm just going to copy the contract address out and just save it stack span. Put it here. Just give it a moment. So this is the smart contract we are going to be working with. Sorry, let me first. It's giving it a moment to load up. Is this one done? Okay, yeah. So basically, the smart contract we are going to be working with has two functionalities: a single read function, and a write function to increase balance. So you can decrease or increase balance. So yeah, of course, I'm presenting. Can you confirm if you can all see my screen?
Yes, we can see it.
All right, awesome. So yeah, this is basically the things that we're going to be working with, a simple read and write function. And so since we have a project set up now, so let's go ahead to work on our config. So we first need to install our Starknet React using npm. So at some point, you might experience certain issues, like dependency issues, when it comes to installing Starknet React. I mean, like you're going to see the issue I'm talking about, like series of dependency issues. So if you experience issues like this, you can just make use of the legacy peer dependencies to like fix it. I think when you use yarn, you shouldn't get issues like this though. I think it only happens with npm. Just need to like point that out. So this is going to install Starknet React into our project, and that is only the beginning. And then, so after this installs, so we'll proceed. Like I said earlier, we're going to be doing a whole lot of plug and play. So we'll proceed to create a Starknet provider file, right, that has basically our configuration. So these are the core importations that you'll be needing to start with. These are the core importation. This one is for the chain. It's either Sepolia or mainnet. So if you want to deploy in Sepolia, you import it from the chains. If you want to deploy a mainnet, you specify it on the chain. And then we have several config as well from the React core. So we have several config as well from the React core, right? And over here, this is our connector. So this is exactly what allows us to connect to what's it called, to our browsers, the likes of Ready, formerly known as Agent, and the likes of Bravos, right? So this is the connector, and this is the wrapper. This is the wrapper for our Starknet config. So this is what we are going to be integrating into our project for us to have access to. Okay, let's connect wallets, let's interact with our smart contract, etc. So let's see, this is done installing. Okay, yeah, this is done installing. So let's let's create a file called Starknet provider.tsx inside our components. So let's just create a folder, name it components. Your file provider.tsx. So you can come back here to copy this code snippet. So this, I'm going to be sharing this documentation, the link to this documentation in the chat box right about now, so you can keep track. So that's the documentation to Starknet React. So now we have to copy this. I think we already copied it. So this is our provider that is going to like allow us to connect to the the Starknet blockchain. So since we're not dealing with minutes, we can just take the minutes option off for now, and then we can just delete this. Right. So now what next? Now the next thing is to wrap our provider in our app, to wrap our app inside the provider. However, if you're using just ordinary React, then this is going to apply. However, we are using Next.js. So this mixes of this kind of implementation. So we're just going to copy this and then save it in our wrapper. So I think that should be in our layout, if I'm not wrong. Yeah. So we are going to wrap it inside here. But then before that, we need to import our Starknet provider, of course. Import Starknet provider. Yeah. So now our Starknet provider is going to be available across all the pages. So so let's quickly spin up our front end. Let's see what we have at hand, and let's see what we can do with it for now. There's going to be a lot of boilerplates there for now. NPM on that. Let's give it a moment. Okay, I think we're up now. That was 3,000. Give it a moment for it to load up. Is it loading? Oh, it's trying to, it's compiling. So it's taking a little time, more than usual. So, and I also need to make mention of something. So after we've done this, after we've done our what's it called, our configuration now, and resolve just now. We say, okay, we'll get back to this. So now, after resolving our configuration, the next thing that we are going to be doing is to work on our wallet connect. So for the wallet connect, we're going to make use of Starkentkit, which I'm going to get back to. But first, let's resolve this error. So this is saying cannot resolve Starknet. Okay, saying Starknet is not installed. So let's just npm install this then. So let's quit this npm Starknet. I think it's going to also run into certain dependency issue as well. Yeah, I thought as much. I think this issue only happens with npm. I think the last time I used Yarn, it went properly. Everything went smoothly. All right, so let's give it a moment for it to. All right, so let's spin up our. Oh shoot, stuff isn't. All right, npm run. Give it a moment. Okay, ready. So hopefully it should work now. So if you have any question or you get confused at any point in time, please drop the question in the chat box. I would pick it up and answer it along the line. So yeah, we have our boilerplate. So so far everything still works so far. So let's refactor this to like have. Let's just delete all this first. Let's go back to. So that should be in our page.tsx. We can just take the whole of this off for now. We don't need them. Okay. This can go off. And then we can take these ones off too. Let's save this for now. And let's add to the global.css. Within background. No. It's here. Okay. So that's what we have now. Okay. So everything is off. Yeah. We need the white background. Okay. Let's go back. Okay, yeah. So we have our empty page right now. So the first thing that we are going to be doing is to work on our wallet connect. Of course, when a user comes in, they have to be able to connect to your dApp, right? So to do that, we're going to be making use of Starknet kits to like pull up what's it called, to pull up our model. Let's head over to the documentation. So this is Starknet kits. Let me share this as well. So we are going to be integrating Starknet kit into our Starknet React. So this is going to give us the opportunity to have, you know, the agents, the ready wallets, the Bravos, and the likes. So it is going to like help us, you know, have that model in our dApp. So the manual installation, I think this lately has not been working. So this might not work for you. You might have to like subscribe to the manual installation. So we first install Starknet kit. So let's click this. Say npm install. Sorry, I already copied it. Then install Starknet kit. So if you experience the same npm issue, you just have to use the legacy peer dependencies. So to like fix the issues for now. Yeah, thought as much. Oh, sorry. Let me copy this out. Okay. That's looking up. So why do we need Starknet kit? This is going to, like I said earlier, just to recap, this is going to allow us to have the Wallet Connect feature in our application, right? So it allows users to connect their wallets, interact with the dApps, and then Bob's your uncle. So give it a moment. So after installing this, Starknet provider, wallet connector. Okay, so there is a wallet connector snippet already here as well. Sorry, let me pull in this. So like I said earlier, when we started the class, that we are going to be doing a whole lot of plug and play. So this is a wallet connector already written inside the Starknet documentation. So you also implement what's it called, the Starknet React. It's been integrated with the Starknet React. If you notice this, these importations, they were gotten from Starknet React core, and these ones, of course, are gotten from what's it called, the Starknet kit package, right? So this hook here, it allows you to disconnect your wallet, right? And this one allows you to connect your wallet. So it gives you access to connectors and gives you access to the connect feature, allows you to connect. And this one is the modal that pops up whenever you try to connect your wallet. whenever you try to connect your wallet to, whenever you try to connect an address, your wallet to a dApp, right? And okay, this is just the usage. This is just the usage. And so the use account hook, I think it makes more sense to address this inside the Starknet React. So yeah, these are the hooks that are being used inside of Starknet Kit. The use account, the use connect, the use disconnect. So the use account lets you have access to the connected wallet, the connected accounts that is attached to the dApp. So if a user connects their wallet to your dApp, this is what you use to pull their information. This use connect allows you to connect to the dApp. This disconnect allows you to disconnect to the dApp. So let's put this in action. So let's just copy these snippets. And of course, let's first create the wallet connector first. Wallet connector model. Let's go back to our code. So we can have that in our component. Wallet connect model.csx. Give me a moment. So we go back to here and print this here. Oh no. I think I've messed it up. Okay. So let's copy the wallet connect model, the wallet connector like snippet, and then save it in here. So like I said earlier, this is what will enable us to, it's a component that we are going to import in our main page that would enable us to connect our wallet and disconnect our wallet at will. So, so this is a component, and then we can just go ahead and import it in our main page over here. So we import wallet connector model, and we make use of it right here. Sorry. All right, so let's save this up and then head back to, let's run this. Okay. So let's give it a moment for it to load up. See if it to load up. Let's see. Compiling. Please, if you're confused at any point in time, don't forget to drop a question in the chat box. I'll pick it up. Okay, awesome. So as you can see, our Connect Wallet model is showing up here already, right? So if I click on Connect Wallet, this should pop up my agent by default. Okay, something is wrong. Aha! So as you can see, so this this model is made possible because of Starknet Kit. Sorry, give me a moment. I think I lost my screen. Can you still see my screen? Okay, awesome. So, okay, awesome. So this model is made possible because of Starknet Kit, and you have a series of wallets open to you, the likes of the controller, the Ready Wallet, Bravos, and MetaMask. So if I want to connect my agent wallet, okay, give me a sec. I might have to quickly stop sharing my screen so I can input my password, security first. Sorry, just give me a few moments. Let me just input my password. Okay. I can go back on. All right. So as you can see, I can't see my own screen. Okay. Okay. So as you can see, the moment I connected my wallet, I can see my address. Okay, awesome. Can you change the size or style or study? Of course you can. You can change it to your desired taste. So this is, of course, this is the wallet connector model. You can change it. This is the configuration here. You can change it anyhow you want it, whatever design that you want. So now that we have our Wallet Connect functionality working, so the next line of action is to now make our contract, make our contract work with the right function, the read function, like integrating the front end now with the functionality on the smart contract. So the first thing we are going to be picking up is the ABI from the contract. So this ABI is going to allow us to communicate with a smart contract. So the API is going to consist of all the functions of your that are embedded in your smart contract, right? So again, it is very important to point out that without your ABI, you cannot communicate with your smart contract. So to pull it, you just come over here. As you can see, copy ABI code. So before we copy that, let's quickly create an ABI file. So let's create a separate folder and call it utils. Utils. Then let's create a file. Say abi.ts. Okay. Okay. So now let's create a const ABI equals to, then we can come back. Sorry, we should be able to export it. Export const ABI. I'm lost in my, okay, there you go. So we copy this, copy the ABI. Please, Chico, take off your camera. So we paste in our ABI here. All right, I think that looks good. That looks good. So this is what your ABI looks like, right? And then the next thing we are going to be doing after importing the ABI, so let's work on a few functions. Let's head over to Starknet React first. See what next. So let's work on a write function now. So if you want to work on a write function, you make use of the use send transaction. So the use send transaction enables you to to interact with to send transactions to Starknet, right? And as you can see, the documentation is pretty much simple and straightforward, right? All we have to do is just to infuse this implementation in our own code. So first things first, we need to import all this. Let's import this first. So copy this guy. So we need it on our main page. So we'll paste it in here. So we import the send transaction, the use contract, the use network. What else again? The use network, the use accounts, for us to be able to, interact with our smart contract. And of course, let's import our ABI as well. Import ABI from, it should be in utils /abi.ts. All right. So we've imported our ABI as well. So let's go back to our documentation. Okay, so we need the use contract. We need the use contract for us to initialize. So the use contract allows you to initialize an instance of a contract, right? An instance of a contract. So it is this contract contract method that is being destructured from this hook is what we're going to use to initialize our use send transaction over here. So let's first copy this out. So it has two what's it called? It has two arguments that we're going to edit just right about now. So for this is going to be the address of the contract that we want to interact with. So I think we should just quickly initialize it here. So say const smart contract address equals to, so let's copy it from our Explorer. We already have it here. Where is it? Overview, contract address. So let's save it here. You can manage it whichever way you can save it in the file, import it in here, whichever way you see fit. So yeah, let's do this. Then we can then use our smart contract address here. Okay, why is this throwing an error? API type of this throwing an error. An example type function name functions. Okay, so this is expecting this format. Give me a sec. Let me see the format of our ABI. So the format of our ABI has this initial input definition. However, it is expecting that it's, let's see what it's expecting. They're expecting an ABI of this type function ABI. They're expecting us to like insert this directly. Okay, there are two ways to do this. You can either filter this ABI, right, and then target this items field, then use this directly inside your code, or let's use an alternative like from Starknet Js. Let's just use let's initialize the contract from using the method from Starknet directly instead of having to use this hook here, because basically even this hook is integrating this this contract method from Starknet inside the hook itself. So let's just import it directly from Starknet. Import contract from Starknet. So why is this not working? Okay, sorry, it's not a small. I think this is meant. Aha, okay, that works. So let's comment this out for now. So now we will now go ahead to initialize a contract instance. New contract. So equals to, sorry, new contract. New contract. So this is going to take in two arguments. This is going to take in two arguments. That is the ABI, and the address of the smart contract you want to interact with. Okay, so yeah, I think so. We can use this since our use contract hook isn't working, so we can at the same time use this. So let's go back to our documentation to see the next steps. So there we can go ahead to make the actual actual interaction, right? So let's just copy this and paste this in here. So this use send transaction is what you're going to use to interact with the smart contract, and this is the method that you will be calling. So it's like this is the method you'll be calling for you to trigger the function call. So now there's something we need to do here. So for the address, we need to replace it with a smart contract address here, right? And so we need to populate. This field, right? This here in this field now, our contract, the function we want to call is what is going to go in here, and this is going to be the argument. So for example, now for example, our right function increase balance, it takes in an argument of amount, right? So it's expecting that we provide an argument there. And then the name of our function that I want to interact with is called, let's copy it from here. It's called increase balance. This is our right function here. So it's called increase balance. You copy it out, you place this with that. And it's going to take one argument rather, which is the amount. So let's say, so for now, let's use an hard-coded value for now. So for us to test if our function works before we now make the value dynamic. So let's say 5 for now. So then let's create a simple button to help us interact with the function. So let's call this button increase balance. Increase balance. Let's just give it a little styling. First name. The width of the pixel. Say 100 pixel. And what else should we give it? Let's just give it a few. Let's give it a rounded padding. Say large. Sorry. So let's have a border. Border say 2, then border black. So now we have a simple button to interact with this function call. So so on click of this button, what do you want it to happen? So make use of the click method, of course, from React. If you're familiar with React, you should know of the click method. So we are going to call the send what's it called? The send function here. So this is the function that is going to send the transaction to the blockchain. What's happening? Okay, sorry, I lost you guys for a moment. Let me reshare my screen. Okay, it's still coming up. Oh boy, I think something is wrong. Sorry, let me reshare again. Screen. I'm experiencing difficulty sharing my screen, so just give it a moment. I'm getting an error saying you can't share a screen. Something went wrong. Let me try see if I can share a single tab. Sorry, what's going on?
You can leave and try joining back.
Sorry?
I said you can leave the call and then try joining back.
Okay, okay. Give me a sec. Sorry, folks, my mic was muted. Confirm if you can hear me now. I mean, confirm if you can see my screen and you can hear me. With thumbs ups. All right, awesome. So, where did we stop? So yeah, we can now like interact with this function, with this contract interaction using this method that was provided by the useNet transaction hook. So if we call this, if we interact with this button, it should write straight to the smart contract as long as the wallet is connected. Okay, let's reload this page so that our button can show up. Okay, it's saying we should make use of, okay, the use client. All right, so let's come back here and bring this back here. All right, let's reload that. Okay, that should work. All right. Our increase balance button is way too big, but I think we can manage that. So let's connect our wallet back. Sorry, is there an issue? It's urgent. Let's give it a moment. Our wallet's connected, not popping up. Okay, yeah. I think it's all good now. So, sorry. All right. So now we can increase balance. Let me just change this to cursor pointer. Cursor pointer. Let's reduce this width to 100. Let's reduce the height to just 50. 20. All right. So now let's try to interact with the increase balance button and see. So as you can see now, it's just popped up our ready wallet for us to sign the transaction. So when we sign the transaction, it goes through, right? So now let's make it dynamic in such a way that your user can pass in an input value, and then you automatically increase the balance on the click of the button. You know, if you notice that we uploaded the argument, the argument for that function in here. So let's just have a simple input here. So first, let's create a separate div. What's going on? Just lost my screen again. Just give me a moment. All right. Okay, so let's have a simple level first. So I'm trying to quickly create. Sorry, I keep losing my screen. What's going on? Text input. So let's have a text input, and then let's have the input. So let's have the type of the input to be number, and then on change of this input field, what should happen? So let's say on change, let's call it, and let's have a function here, undo thing. So let's have our function definition over here. Const. Shit. Const handle change equals to. So now we need to pick up the what's it called? We need to pick up the value that is going to be typed in here by the user, and then set it in state. We'll be making use of use states to, like, fix that up. Let me delete this. So say, what's the type of view? Sorry. React dot, sorry, change. Oh, I'm lost my screen again. Sorry about this. Okay, I'm back on. So change HTML compute elements. So this is going to help. Now I have to, like, typecast this, because I have to, like, impute the type for this, because I'm currently using TypeScript, and TypeScript it's all about you specifying the type. You need to annotate. If you don't annotate, it will throw an error. So we can easily pick up the value that is being passed in here. Let's just save it somewhere here. Say const value. Now it's going to be e.target.value. So whatever value is being passed in here is going to be saved inside this value over here. So now let's proceed to save on change of the input field. Let's proceed to save the value inside the use state. Let's have a const, sorry, say increment value. Sorry, I'm used to increment value, and then set increment. Let's open this back up. Set increment value. So use state. So this is going to temporarily, save our inputs value. So now, since we have this here, so we can proceed to save the data inside the set increment value. So paste this in here. Okay, this is showing an error saying okay, so this is expecting a number. However, value is returning, is sending back to us a string. So we can just easily typecast this back to number. Say number. So yeah, our error is gone. Then so yeah, so we can proceed to make use of the increment value in here. So that way our input value is going to be dynamic. So let's put the increment value here and save up. Let's go back to our front end. Let's just give our text input a little bit of shiny stuff. The class name, let's give it border. That too, border, I'm sorry, border black. So let's save this up and back. All right, let's give it a bit of spacing. Class name, flex, space X, say 2. And then margin top, let's give it a 2 at the top as well. So let's make the two of them have the same height. Well, the front end is not the best. I mean, the the interface is not the best, but it works, right? Okay, I see that. Thank you for that. Set increment value. Thank you, Joe. Okay, Joe. Thank you for that. So let's save this back up and go back to our code. Okay, yeah, I think this is looking a lot. It's still looking better now. So let's test if our implementation works. So let's pass in the value of say 20, and let's click on increment balance. So as you can see, Ready Wallet is popping up, asking us to sign the transaction. And we can confirm. So now the transaction has gone through. If I check my my wallet now to see the increment increase, to see the interaction, you would see it over here that the function call has gone through. Yeah, increase, yeah, that works. So yeah, and as our write function works, if there is anything confusing up until this point, please drop it to the chat box, and then so I can address it. So so this basically, this is the building block. If you have more complicated, function calls, it's literally the same way that you're going to be doing this. And it should also be of note that Starknet has something called gasless transaction. Like you can pay for your your user's gas fee using Avenue. That's another protocol entirely that you can just read up the documentation to see how you can integrate gasless transaction. So, and then it should also be of note that Cartridge, one of the wallet providers, has inbuilt there's also it has what I call it. It has this inbuilt gas sponsorship. So if you integrate Cartridge wallet inside your protocol, inside of application, you can easily you can pay for your users gas using that, automatically using that. You just have to go through the documentation as well to understand how session works. So session is also pretty much simple and straightforward. It's just simple plug and play, just the way we doing plug and play so far. Everything you're looking for is in every single documentation on all their documentation, Starknet React, Starknet Kit, Cartridge documentation, and the likes. So now that we have our write functions working, let's go ahead to make our read function work. So let's just quickly write a quick boilerplate to say that, okay, yeah, this is our text. So let's just have a quick div here. Sorry. Let's have a quick div here. Lost my screen again. Okay, back up. So a quick div. Come on. Sorry, my screen is going on and off. All right, back on. So let's have a quick div that says text. Say total balance is right, and then what is this? Total balance is this. So I think we should also have let's also have a button to let us query it at every point in time. Of course, we're going to put it in use effect, right? But let's also have a button that would enable us to query it anytime we want to query it. Let's put this inside an H1 first. Then let's just have a similar button. But we're going to take this off for now. So this is going to be, say, fetch balance. Let's proceed to, let's just style this a little bit. Class name, flex, this X, let's give it, let's say 2. Yeah, let's set that up and check. Okay, this is looking a little bit ugly, but then it's what we are going to be working with. So let's just give this a margin top, say 2. Okay, so I think it's high time I reduced this. Oh no, too small. All right. So now this doesn't do anything yet. What if we want to use DB to store off-chain data? Do you integrate Node.js and Frontend with Cairo smart contract? So it depends. It depends on the product you're building. It depends on what you want to do, the kind of service you are offering. If the kind of service you are offering requires that you make use of database to store some off-chain data, of course, why not? You can integrate it. So, for example, we have events. We have events on your smart contract. So events that are emitted, right, on your smart contract. Let's say you want to pick them up, to say maybe update a recent activity page in your product. So you can basically just pick this event and send them to your database, so you can always query it anytime you need it. Of course, there are other tooling that you can use to fetch this event from your smart contract. Yes. However, if you want to go through another route by sending this event to your database, of course. So everything is basically dependent on your product architecture, what you intend to achieve. I hope that answers your question. So how do you integrate Node.js and frontend? It's just basically, if you want, it's just basically the same way you integrate normal database stuff. Once you have data you want to send to your database, you just pick it up and you send it to it. There's nothing complicated. So right. So now this does nothing. Let's go ahead to fetch our balance. So of course, let's head over back to so you can make use of the use read contract. However, having double mind as regards this, because this ABI format is expecting something entirely different from what we have in our ABI. So let's make use of Starknet Js this time around to do our read functions. Let's see. Where do I get that from? Starknet Js. So we'll be importing a couple of things. Starknet Js. We're importing a couple of things so we can see. Interacting with your contract. So yeah, of course, if you want to read, you first need to initialize our RPC, our provider, our RPC provider. We need to initialize that, and I think this one is making use of meta class. Of course, let's just dive right into it. I've lost my screen again. Just give me a moment, please. My screen is coming up. All right, I can back up. So let's import a few things first from Starknet. We already have a contract there. So import the RPC provider, because this is all you're going to use to initialize the provider that would use to interact with the smart contract. Which other thing again? Let's import the constant, likes of the Starknet, the chain ID, and etc. So let's initialize our provider. So const, oh Lord. Sorry, lost my screen again. So okay, provider. Let's see, new RPC provider from Starknet, right? And it's going to take in a couple of fields. So the likes of the node URL, the chain ID, and then let's just write a boilerplate for that for now, so you just fill it in. The node URL, something is going to go in there. The chain ID, so that to know So know the chain ID that we are trying to interact with, and then the spec version. So for the node URL, we basically need to pick up an RPC key. So we can use the public RPC key from Blast API. So let's head over to Blast API. Blast API. So these are the public APIs. So let me just copy this and send it to the chat box as well. So you just look for Starknet. So yeah, these are the public endpoints. Make sure you're using the version 8 because the version 7 will not work. So the current upgrade on Starknet is not, is not going to work with the previous RPC. So you need to make use of the version 8. Then copy this, head over to our code. So this is going to be, sorry, it should be a string. So paste it here as a string, right? And then next is our chain ID. So this constant method from Starknet has a couple of things inside of it. So it's from there that we'll be picking up the Starknet chain ID constant dot Starknet chain ID dot. Since we are dealing with Sepolia, we click on SN Sepolia. If you're dealing with mainnet, you click on mainnet. So oh shoot, there is a comma here. There should be a comma here. So the spec version, so since we are using a version 0.8, the spec version now is going to be 0.8.1, 0, which is a half cost has given us the option. So now this is our provider that is going to it's going to serve as a gateway which will enable us to interact with which will enable us to read from our smart contract. So we have our provider up. So now let's create an helper function that would enable us to read from our smart contracts. So let's just say const undo contracts read. So it's quite imperative that we make use of async and await here, because by the time it is fetching from the blockchain, we need to wait for it to like resolve, right? So if you don't wait, you're just going to get an undefined response. So it's very important that we use the async await method. So now, the next critical thing that we have to do is to initialize our contract, right? So just the same way that we initialize the contract for the write function, we need to initialize the contract for the read function as well. So we can say const contract. Sorry, give me a sec. What's going on here? Const contract equals to new contract, and then so this is going to take in 3 arguments, which is our ABI, then our address, a smart contract address, and then most importantly our provider that we initialized over here. So this is where the provider comes into play. So now what next now is to proceed to interact with this this contract that we initialized. So we can say, let's say const response now is going to be, so we can just say contract and call the function directly. So the function that we want to call directly is the get balance function dot get balance function. So let's say your read function requires oh my, you can't, sorry, can you see my screen? Please, if you can see my screen, thumbs up. Okay, awesome. All right. So let's say your read function as argument is expecting argument. You can just pass it in here, the same way that you pass in your arguments here. So just pass it in there, and then you're good to go. So for now, let's first console log. Let's first let's first console log our data, console.log. Let's first console.log our response to see what is coming back from the smart contract. So okay, let's do this first. Let's to make things faster. Let's call this function. Let's call this function in our button using the onClick. So say onClick. Click. Sorry, this doesn't matter. You can just call it. Click. I think this looks good. Let's save this up. Let's go to our front end. Let's open up our console. Refresh. This is not. Let's give this a moment for it to load up. Okay. So let's try fetch balance. Let's see. Oh, contract address not found. Contract not found. Something is wrong. Let's check our code back. Where is the issue coming from? Oh, this is. Remember I made mention of something earlier that we needed to make use of async and await, right? Now, the fact that we're not awaiting this function, this call that we did here, which was why we got this, undefined method. Promise is still pending, so we need to await this promise here. So that is where our issue came from. Let's save that up, then come back like this. Fetch balance. No, let's reload the page first. Fetch balance. Why is this still not working? Why is this still not working? Need about this. What could be wrong? RPC is defined. Is it because of the contract becoming new contract? Contract. Did we make any contract definition on the top? Oh, okay. Let's try this again. This is first. Okay. What could be wrong? Contract is not found. Is our function called wrong? Get balance. Here it is. Here. Where's the ABI? ABI is also there. Oh, I could be wrong. Let's try restart. Let's try and restart this first. Then run dev. Okay. RPC. So call. See, this is showing an RPC error. We're using a blast. Oh, shoot. We are currently using the mainnet RPC. I meant to make use of the Sepolia. We copy the mainnet instead. No one caught that. Oh, come on. Where's the public? Yeah, Sepolia. So yeah, I meant to copy this. We're using the mainnet instead, which is why it was screaming contract not found, because of course the contract is not deployed on the Starknet mainnet. So let's save this up and let's go back to reading our contract again. Hopefully that should resolve the issue. Okay, so let's fetch balance. Yeah, as you can see now, we have a balance of 59. So this is coming in as a big number, right? So you have to, typecast it back to like normal regular number so your users can pick it up. So we know that our read function works now. So let's do it such a way that on page load, you can easily see what is it called? You can easily see the total balance before you start interacting with the smart contract, with the front end, like from scratch. So let's have the use effect. Use effect. This work. Well, I think this should work. Yeah, okay, yeah, it looks good. So then let's call this here. So on page loads, it's fetches the balance and then saves it for now. Okay, let's save the response in a state so that we can pick it up and display it. And then we can do that using the use states once fetched balance, then set fetched balance. So use state 0 for now. So we can say set fetch balance. Instead of console logging it, we can just save it straight up. So don't forget, what is coming is a big number. We need to typecast it back to a regular readable number that our user can see. Okay, what else has not been done? Okay, yeah, so now let's go ahead and display the results here. Say fetch balance. Save it here. Save up. So now let's go back to our page. I think if we just click on fetch balance, it should set. Okay, it doesn't. Oh, I think we added it in the wrong place. It should be here. Fetch balance. Exactly. So let me put a little space. Span. Hash name, margin left. Let's give it say 2. Come back. So as you can see, our contracts, we can read our contract safely now. So let's update this balance. Say let's add like 10 more. Increase balance, pops up the ready wallet. We confirm. So let's fetch new balance. Let's give it a little time. As you can see, on fetching the new balance, it updates straight to 69. So we can proudly say that function, our read and write function now works on the front end. So I think looks like they're going to be ending this class early today. Please, if you have any questions so far, please throw them at me now. Any questions that you have also, please throw them at me. So, okay, can you drop the question in the chat box? Or perhaps open your mic and just ask the question, since you're almost done, by the way.
Okay. Good evening, boss. Can you hear me?
Yeah, I can hear you. Go on.
Okay. My question now is, let's say, for example, so this question I'm asking is based on a read function. So
Okay.
let's say now that you created a function that, let's say, for example, holds some data, right? A function that you use to read some data from the storage and display them directly on the front end. So my question now is, let's say that somebody visit the front end. So when you have already hosted the front end, and that person seems to refresh the front end, does it mean that it have to refresh the data again? Or how fast is this, like the fetching data?
Okay, yeah, the data fetch is actually very fast, right? So now, to ensure that your read function updates at every point in time, in your use effect, you can make use of certain dependencies. Like you can specify them here, right? So let's say, for example, that okay, on change of something, let's say on change of anything, maybe on your page right now, you want it to fetch the data again. So you're going to drop the dependency inside this use state. So whenever that dependency, if changes happen to that dependency in your use state, your use effect is going to run all over again. But with this one right now, this one only runs once when the page loads, which is why I had to like add a function, a button to just fetch instead of us loading the page at every point in time. However, if I wanted to like keep fetching at every point in time, I could just set a simple timer here. For example, it's just an example. It's not a very good practice. I can simply set a timer here to fetch data, let's say every 1 second. To just make this call every 1 second or every 2 seconds or every 3 seconds. Do you understand? So for your own case, you can just set dependencies here. So your use effect is going to be dependent on those dependencies. So whatever, if anything, if changes happens to those dependencies, your use effect is going to run again to like update the front end. I hope that answers the question.
Yes, it's another question. Thank you, boss. Thank you very much.
Awesome. So is there any other question before I move ahead? So let me once again just drop some of those documentation. So for the Starknet React, you can pick it up here. So it's the choice is yours. You can decide to make use of Starknet React, or you can decide to make use of pure what is it called? Pure Starknet Js, or you can decide to go through the route of using the scaffold stack. So this is scaffold stacks documentation. You can in your free time, you can always come here to check the documentation. Is pretty much quite easy to follow, and they have several hooks to to interact with your smart contract. That's of use scaffold read, use scaffold multi-write, use scaffold write contract, and lots of functionalities that you can pick up. And I think they also have a challenge, like an interactive challenge. Can't see. I'm not sure. I can't find it. I think they have an interactive challenge that you just have to let me see. I think you should be learned. Aha, speedrun stack. So they have an interactive challenge that you can also work with. This is the Starknet here. I think you're already familiar with Starknet. Check the challenges. So they have like front-end challenges that you can work with. So in your free time, you can also go through what's it called? Go through the documentation to see how it works, see how you can make use of it. And it's very important that you keep learning these stuffs. They are very easy to forget, not gonna lie. You have to keep practicing them from time to time. Can we ask you questions when we encounter difficulty doing that? But of course, please. I am not currently on your group right now, but I would be asked to. I will be added to the group today. So if you encounter any development issues, you can always reach out to me on the group. I would pick up the question and respond as soon as possible. So as I was saying earlier, you can also check out their challenges. Their content challenges. See how you can. The instructions are there. Yeah, it's just similar to the way what's it called? To the way Starknet app works for you to learn development. So I think that's that. Which other documentation have I not shared? Starknet React, Starknet Kit. Okay, Starknet. Have I shared the last API? I think I already did. Starknet Js. Yeah, there you go. Okay, yeah, I think that should be it. So hey guys, it was nice. Thanks for having me. It's been a really nice ride taking you guys. I hope you were able to grab a few things from this class, and hopefully would see you at the top. And I'll see you guys.
Yeah, thank you so much. Thank you so much, Mr. Kensman. Please guys, come please.